Hi Year 10s, in this video I'm going to be going through sketching parabolas using factorization. Of course, we're making the assumption that you have done all of that factorizing in our previous unit, but this time we're going to apply it to sketching quadratics and parabolas. So we've explored the raw skills of factorizing, completing the square and null factor law, and we're going to apply those so if we can apply those, then we can sketch a parabola. So let's consider if I had the parabola, the quadratic equation, y is equal to x squared plus 2x minus 8. Well, in the past, you might have actually seen just this, and we've just asked you to factorize this, what we will call, in this case, this is a monic trinomial. Okay, so of course, when asked to factorize this, then we might sort of ask you to multiply find two things that multiply to give minus 8, and they add to give 2, and then of course we can use grouping to factorize those. So for example, if I've got 4 times negative 2 is negative 8, and 4 plus negative 2 is 2, then we could, what we were doing is we were splitting up this second term. So 2x actually becomes plus 4x and minus 2x, and then minus 8. And then what we're doing is we're doing grouping, because the highest common factor being x of these two, which would give us x plus 4. And of course, I've got this x plus 4. The hint was that we really wanted to see this again. And what would be out the front of these two? Well, negative 2 would be out the front, and we could then group them together. X plus 4 is our factor for both of those. And if I multiply it by x minus 2, we have factorized that quadratic. Now, why are we doing this? Well, if we have a look at the expression, basically what does the y value, what is the y value of both of those points? Well, hopefully you can see that on the x-axis, the y value is 0. Obviously, it has a height of 0 above the x-axis. So we're going to be letting y equal 0. So can you see there? Now, if I've got this in factorized form, so if I factorize, I've got the same expression here, but this time I've factorized, we've now got y is equal to x plus 4 times x minus 2 factorized. Now, we should also know to find the x-intercepts, just like anything, whether it be linear or anything for that matter, the x-intercepts, we let y equal 0. So if I do that, clearly I've got this, and now from what we've learned previously, we can use what's called the null factor law. The null factor law basically means that, hey, I need to solve this. There's two ways this can equal 0. Either x plus 4 is equal to 0, either that equals 0 or that equals 0. There's two ways, either that equals 0 or this equals 0. So we could then, that is going to give us, I don't know why I did a bracket there. Either that gives us 0 or that gives us 0, which means that our two solutions, when we've been solving in the past, if I subtract 4 from both sides, x equals negative 4, and if I add 2 to both sides, x is equal to 2. These are my two x-intercepts. So what do we need when we're sketching a graph? Well, first of all, we need the shape, which we'll get to in a moment. But basically, we basically need the shape, which is, we basically got a parabola. Now, in our parabolas task that we've just done, a parabola self-directed task. So it could look like this or this. It could be wider or narrower, and a lot of those sort of, there's quite a few things which affect those, but basically we've got the general shape. Let's just assume that for now we're just looking at our happy parabola or our sad parabola, positive or negative. And we've also got where it turns. So we've got the turning point. Now we'll get to the turning point a little bit later, but for the time being, what I hope you can notice is that, which we'll get to in a second, is that the turning point it's symmetrical. It's actually halfway between where it turns. It actually turns halfway between the two intercepts, and we've just established the two intercepts for this are -4, which we can see here. There's our point here, our X-intercept. So if I label those and +2, and we want to basically, we can sort of find that the turning point where it turns is halfway between those 2 points. So the turning point we'll get to in a second, and of course we want the X-intercepts now. And finally, the X-intercepts, and finally we've got the Y-intercept. And the y-intercept is actually pretty easy because if you think about it, we've got a graph of y equals x squared plus 2x minus 8. If the x-intercept is when y equals 0, the y-intercept, we let x equal 0. And that's quite nice because if I was to let x equal 0, 0 squared is 0, 2 times 0 is 0, and we're just left with y is equal to -8. So in other words, the constant, when it's in this form, the constant y equals -8 is that there is the y-intercept. So you can hopefully see that the y-intercept is here, which is at -8. Okay, so now if we start to bring all those together, the final thing is that given the symmetry of the parabola, find the coordinates of the turning point. So we should hopefully find that we can sort of find that point in between. Now, how do I take the average of 2 points? I've got an x-intercept. At -4. And I've got an x-intercept at 2. And of course, if I was to find the average of those 2 points, I'm going to add them together, -4 plus 2. And I'm going to divide it by 2 because we've got 2 points. And if I do that, that's going to be -4 plus 2 is -2. -2 divided by 2 is -1. So, and you can see that. You can see that -1 is this sort of what we call an axis of symmetry because it's sort of, it's like a mirror image, both sides. You can see there that anything that's on this side of it is also going to be a mirror image on this side. So this is what we call for later is the axis of symmetry. And it's always about the turning point. It's symmetrical about the turning point. Okay, so we've found the x part, but of course what we need to do now is -1. We need to find the y. So how do we do that? Well, when x equals 1, let's sub it into the equation. When x equals 1, we've got our equation of y is equal to x squared plus 2x minus 8. And so, of course, if I sub that in when x equals 1, well, what does y equal? Well, we don't know yet. We're going to find out. Substitute in here. Wherever there's an x, I'm going to replace it with 1. 1 squared is 1. 2 times 1 is 2 minus 8. 3 minus 8 is, just quickly, what have I done there? 1 squared plus, it's subbing in -1. Why am I subbing in 1? That's a bit silly of me. So that's going to be -1. And so let's do that again. -1 squared plus 2 times -1 minus 8. That's going to be, well, -1 squared. -1 times -1 is +1. And then we've got 2 times -1 is -2 minus 8. 1 minus 2 is -1 minus 8 is -9. So we have now found the position of the turning point. There are other ways to do that, But for now, we're just going to stick with that using symmetry. Okay, so we have now sketched a parabola. There are other ways to sketch it. There are other forms and things which we'll look at later. But essentially, like if you can factorize and then use the symmetry, that is one way of sketching a parabola. Okay, and you can see there that we've got our key points. And knowing that this is a positive parabola, we know that it's going to take this sort of shape. It's going to look like a little smiley face. We'll get into into that a little bit later. But basically, if I rub all of that out, hopefully you can see there that because this is positive x squared, then we've got a little smiley face. Positive quadratic or parabola. All right, so a little bit of theory, which of course is in your notes there, and that's basically exactly what I went through, that it says that to find the y-intercept, we let x equals 0, and that we factorize if possible, and we apply the null factor law. Okay, so that's exactly what I went through to sketch and find the x-intercepts. The y-intercept is, of course, in this form. The y-intercept is c because we're letting x equal 0. Okay. To find the turning point, then we know once we know the two x-intercepts, 1, 2, it's bang in the middle. We can find the x value. So we can take the average of those 2 points, 1 plus 5 divided by 2. Or you could hopefully see, we know that halfway between 1 and 5 is 3. So that would be find our axis of symmetry. Once we've found our axis of symmetry, then we can then go ahead and substitute that value of x into the equation. So you would then throw x equals 3 into your quadratic and whatever that happens to be. Okay, clearly that's going to be something in front of x squared. You could have something in front of x and so on. Okay, so that could be anything. And that's just a some general theory about what we're doing when sketching these. All right, now let's go through and do some of these ones. Okay, now we want to first of all sketch these graphs. We want to be using the x-intercepts to help us find the locations of the turning point. Okay, so we want to factorize. Now, first of all, this is not a monic trinomial. There's only 2 terms. Now, we could do one of 2 things. We could basically turn this into a trinomial, which means that I've got 2 things that multiply to give 0, and they add to give -2. And of course, that would be 0 and -2, 0 and -2. That's one way of doing it. Another way of doing it is just taking out a common factor. So if I've taken out a common factor, we can do it like this. X times x is x squared, x times -2. This is now factorized. Okay, so you see here, it's a little bit of a tricky one, but basically these 2 numbers, usually what we would do is we factorize with a 0. So over here, it'd be x plus 0, which is just, of course, this x here, and x minus 2. That will still work doing this, but often here it's just best to take out a highest common factor. That, can you see there, when adding 0 is just literally that, and x minus 2 is that. So we could do it this way, we could do it both ways. So I've done it both ways for you. Now we've factorized. Now let's, of course, see what we can do. We know that the x-intercepts, we let y equals 0. And then I want to solve. And while in the past we've been factorizing these using the null factor law, what does that mean? It means that equals 0 or that equals 0. X minus 2 equals 0, which of course, well, that's easy. X equals 0 or x equals 2 are my 2 solutions. So when sketching this parabola, what you can see is that hopefully you can go, it's going to look, is it a positive parabola? Yes. So we're going to have this sort of shape. It's going to come through the origin. It's going to turn, and then it's going to turn, and I've got here x equals 2, x equals 0, and hopefully you can see that now we're going to need a point to find the turning point. The turning point is going to be halfway between those two. This is what we call the axis of symmetry. I'm just going to write AOS for short. And of course, you can hopefully see that, well, halfway between 0 and 2 is 1. X equals 1. That is at x equals 1 is where it turns. So for the turning point, let's just finish this off. The turning point is at, well, we're going to, if you want to do it the long way, 0 plus 2, and I'm dividing by 2. 2 divided by 2 is 1. Now, of course, that's at x equals 1. I now need to sub it into the equation. When x equals 1, then y is equal to 1 squared minus 2 times 1, which is 1 minus 2, which is negative 1. So now we can sketch our graph. We know that it's the coordinates we want to label. 1 and minus 1 is where this graph turns, the turning point here. And we can know that all from symmetry. Okay, let's go through this one, and then I'll get you to have a chance, and also get you to pause it and to try the next one. Likewise, over here, this one's a trinomial. So we know that with the trinomials, we can just multiply to give and add to give. So multiply two numbers which multiply to give 5, and add to give minus 6. Now, what are they? 1 times 5 is 5, but negative 1 times negative 5 is 5, and the only way we can get to minus 6 is if I do it like that. Okay, so that's the only way we're going to get those two to be satisfied, which means that, of course, hopefully you recognise that gives us x minus 1, x minus 5 factorised, but no, now we've got to consider that this is an equation with y. That's now our factorised form. Okay, and we've done that because the X-Intercept, we want to let y equal 0. Really important to show that and to say that step as well. You know, I want you to write, I'm not writing this out. I'm writing this out for a reason. I would like you to write that out in doing your working. It's really important to show, hey, if you've done that and you've made a little mistake, you can still get some marks for correct procedure. Okay, so let's do that. Y is equal to 0. Hopefully you can see, how do we solve this? Well, there's two ways. Well, we know that either this equals 0 using the null factor law, or this equals 0. Hopefully you can see. Now, when you've got fractions and things, you might want to actually write it out a bit more, but I think it's obvious from there that x would have to equal 1. And finally, x also would have to equal 5 over here. So there's my two solutions. We'll get to examples where you've only got one intercept, but for now, if you've got two unique solutions, then there are two. So that's going to be, so we've got 1 and 5. There's 1 and there's 5. I'll put in x, and I'll put in y. And of course, the y-intercept is the easy part. The y-intercept is when x equals 0. And when I do that, if I've got y is equal to, let's sub in 0. 0 squared minus 6 times 0 plus 5. I'm looking at this equation here, by the way. That's going to be 0 take 0 plus 5, which if hopefully you're starting to grasp the concept of the y-intercept in this form is just simply the constant here, which is 5. Okay, so there you go. Let's put that down. Let's go that that's 5. And now let's sketch our parabola. We're sort of not quite there yet because we sketch it, it comes through. It's going to turn halfway between the 2 points. It's going to go up like this. And of course, we're not quite done yet because we need where it turns. Now, of course, where it turns, this is our axis of symmetry. I'll write AOS short. And that is going to be halfway between. Well, You don't necessarily have to go 1 plus 5 is 6, 6 divided by 2 is 3. We hopefully can see that halfway between 1 and 5 is 3, but of course we need to find the, so we could do it like this, 1 plus 5 divided by 2, 6 divided by 2 is 3, and that's to find our x part of the turning point. Let's find the y. So the y is when x equals 3, what does y equal? Y is equal to, let's sub it in there, 3 squared, take 6 times 3 plus 5. We can see it's going to be negative, can't we? We can see it's well and truly below the x-axis. So if we don't get a negative result, we've made a mistake. 3 squared is 9, minus 18 plus 5. 9 plus 5 is 14, take 18 is minus 4. So there you go. We have now sketched two parabolas, and of course we really started off with that whole concept of factorizing first. So we factorized, we then applied that and used the null factor law. We've done that before, but we haven't done that with sketching and finding the turning points. So of course we're just going an extra couple of steps to what we were doing in our last unit. All right, hoping that that's making sense. Now, just quickly, I'm going to now leave these ones open here. Now, I'd like you to pause it and to try have a go, looking back on the previous two, and have a go at these. Now, I'm going to reveal my answer shortly. So if you are watching, can I get you to pause it, have a go, and I'm going to reveal my solutions in a second. All right, so here's my solution for these two. And again, I'll really important to jot down and show all of your working sort of as concise as possible. But really, there's a couple of things. First of all, we need to factorize first. So we're factorizing. So I factorize this one. I've used the highest common factor of x. So let's put x out the front. X times x is x squared. And x times minus 6 is minus 6x. So these ones with two terms, we can do it that way. Over here for the one with three terms, we needed to find two things that multiplied to give 7 and add to give minus 8. They are minus 1 and minus 7, so we've now factorized, and then we've then had to use the null factor law to find that my x-intercepts are 1 and 7. I could then mark those out on my sketch, and also the y-intercept is that constant there, which of course is 7. Now I then had to find, in both cases, when I found them slightly different, I found over here that x equals 0 and 6. Halfway between 0 and 6 is 3, but of course we could have showed it like this if we wanted to. Then finally, we then needed to substitute when x equals 3, what does y equal? Y is equal to sub 3 in 3 squared, take 6 times 3 for this one, which was negative 9. That gives us our turning point. And of course, now when we sketch that with our intercept, we are now done. Okay, so please, I've not sort of showing too much extra working that you don't need to show. You really should, you should be setting out your questions like this. Now, there's one last thing I wanted to go through with you, and I'll do it really quickly, and I'll just go through one example, and that's when we have what's called we're sketching the perfect square. So before, now, if I look at this, we've got a trinomial, we've got a monic trinomial, we've got, we always try to factorize first if we can, and of course I multiply over here to give two things that multiply to give 9 and they add to give 6. Well, just remember that we can get the same number, we can get a repeated factor. So 3 times 3 is 9 and 3 plus 3 is 6. So of course if I sketch that out, we're going to look at that, that's going to be x plus 3, but it's going to be repeated, x plus 3. So when I do the null factor law and I let y equal 0, then of course that's going to give me just one solution, which of course is, what is that? X is equal to minus 3. How do you get a turning point? Well, you've only got one intercept. this is only one intercept. So let's think about it. If I sketch my graph, if I've got one intercept, and that is at -3, but it still has that shape that we've all sort of agreed on is a parabola. We've looked at it. We've done a parabola self-directed task before. So that is going to have this shape here. Now, just so you know, it has this shape, but if it touches just the once, then the turning point also happens to be the intercept. Okay, so that's going to go up and keep going up. It's going to go up at y = 9. And you can see that when we sketch this, the turning point is the intercept. So this turning point -3, 0 is actually, well, halfway between one point while we're still at that same point. So there you go. This is our axis of symmetry. Happens to also be also happens to be the X-intercept as well. Okay, so there's a couple of unique ones. If you have a repeated factor and you only have one intercept, then this is also the turning point as well, or the x coordinate of the turning point, if you like. Okay, so that's just one little extra thing to do. So likewise, if I was to ask you to sketch something like this, x squared plus 8x plus 16, well, if I had two things, just very quickly, two things that multiply to give 16 and they add to give 8, 4 and 4, then we could then basically sketch this out as x plus 4, and if I was to let that equal 0, that would be x = -4. And look, those ones are pretty easy to sketch because the x and the y, the x intercept, there's one of them, and it also happens to be the turning point. And we're basically done with that. There you go. There's our turning point. There's our x-intercept. Only touches once, and of course it goes through the point y = 16. All right, that's it for me. Hopefully that is making sense as you completed your notes. Note, this is not something you're just going to do a couple of questions, you're just going to get it. If we look back at the process for all of these, well, let me just talk about it one more time, and that is that first of all, with these, we generally need to factorize first. This is what you're going to have to do for every single problem you're doing for these. Step one is factorize. So hopefully you were doing that well in our last unit for quadratics introduction. Then we've got to use and apply the null factor law and find the two x-intercepts. And then from there, use the symmetry of a parabola such that the turning point is halfway. Find the x value first, sub into the equation to find the y value. As you can see, there's about 5 or 6 steps there. Need to practice it a lot. So I'll leave you to it. Hopefully that made much sense, but you're not going to necessarily get this straight away. You're going to have to really practice many of these. Hence, there's questions here that I've got. You should be doing as many of those as possible during your work time. Thanks everyone, and I'll see you next time.